Alright, we are moving on to polynomial multiplication. We did addition and subtraction, and remember we're going to save division until later because it's very, very different. So, multiplication. If we have two monomials, we basically just want to combine all of the parts. This is really 5 times x squared times 4 times x cubed. So if we want, we could rearrange it so that we had 5 times 4 and then x squared times x cubed. 5 times 4 is something we can do in our heads, and then we can use a rule to simplify our x's and get to the 5th power. Chances are you guys don't need to show that much work, and that's totally okay with me. So the next one, we have numbers, we have a's, and we have b's. I'm going to show you, again, maximum amount of work, just so we know where our numbers are coming from. So if we have just our numbers, it's 3 times 6, and then we have an a squared, and then nothing in the last parentheses. And then our b's, we have b cubed, b squared, and then finally we just have c squared, nothing to combine it with. So we can combine all these guys together separately. 3 times 6 will give me 18. A times a squared gives me a cubed. We end up with 5 b's and just 2 c's, and we're done. Now if I want to multiply a polynomial by a monomial, hopefully number a, or letter A, is one that we can all do. We're basically going to distribute. That 5 on the outside needs to be multiplied to everybody on the inside. 2x squared, x, and 4. So 5 times 2x squared will give me 10x squared. 5 times x gives me 5x. And then 5 times 4 gives me 20. We've done ones like that before, but we haven't done ones like b before. But the same concepts apply to this one. I want to take what's on the outside here and multiply it to each one of these terms. So I have 2x squared y that I need to multiply by 6xy. And then I also need to multiply 2x squared y by 8x squared xy. And then we can treat these as totally different problems, very similar to these ones that we did here when we're multiplying stuff all together. So if you want, you can show some more work. But hopefully you've gotten the hang now that we're going to do 2 times 6, which is going to give me 12. X squared times x will give me x cubed. And then y times y gives me y squared. Do the same thing for this one. We want to add 2 times 8. X squared times x squared gives me x to the 4th. And then y times y squared gives me y cubed. And then double check that we can't simplify anymore. These two terms are not exactly alike. I have x cubed y squared and then x to the 4th y cubed. So even though they have x's and y's, they're not alike, so we can't combine them, and we're done. So we've done monomial times monomial, a polynomial times a monomial, and now we're going to do binomials times binomials. This one is the one that might be the most different, but the rules of the other ones still apply. I'm going to show you 2 different ways to do this, and then you can choose which way works the best for you. The first one is something called double distribution. So we have x plus 2 times y plus 7. So if I just had given you x, you would have taken x, and you would have distributed it to those 2 things. And then if I was to just give you the plus 2, we can do the exact same thing. This plus 2 needs to multiply to both of those guys. And we call that double distribution because we're distributing twice. So let's actually do the problem. X plus 2 times y plus 7. We need to distribute twice. So let's just take our x. And this x has to multiply by everybody in the second polynomial. So x times y will give me xy. And then x times 7 gives me 7x. And now that we've distributed the x to everything, we need to distribute the 2 to everything. So we get 2 times y, or 2y, and then 2 times 7, which is 14. Double check to see that we can't simplify anything else. X, y can't be combined, the x and the y can't be combined, and 14 can't go with anything. So we're done. If you like that way, that's fine to do everything that way. It will always work out. But vertically is another option. We can set these two things on top of each other and multiply like we do back with just numbers. So we can do 7 times 2, which will give me 14. And then 7 times x, which gives me 7x. And then we can do y times 2, which will give me 2y. And then y times x, which gives me xy. And unlike everything that we did before, we can't just add our columns up because they're not like terms. So we can write them in some order, just like we did here. We end up with the exact same thing. xy plus 7x plus 2y plus 14. Whatever way you prefer, please continue to do that way. Alright, here's another one. Go ahead and pause the video, and I'll put the answers up here and make sure that you can do it all on your own. Alright, the answer you should have gotten is a squared plus 1a minus 12. The one you can take or leave, but you need to simplify these two things right here. Since they're like terms, negative 3a and 4a, you have to combine them. Don't leave your answer as those 4 terms when you can combine. Alright, here is some more. A couple of these are a little different than before. D and E is pretty special. I'm going to walk through D and E, and then you can try C on your own. So D says that I have a plus 4 all squared. Most people are tempted here to take the square and distribute it. But that only works if everything on the inside of our parentheses is being multiplied. And in this case, it's not. A and 4 are adding, so we cannot distribute it. Instead, what it means is that I have 2 of these things. I have a plus 4 times a plus 4. 2 of the exact same thing. Like x squared means x times x. So if I was to distribute this first a here, I get a squared plus 4a. But if I distribute the 4, I get 4a plus 16. Now when we combine this, something special happens. We end up with a squared plus 8a plus 16. And this pattern will happen every single time you have something squared. This one is your first term squared. So a was our first term. A times a gives me a squared. This is always 2 times your first term times your last term. So in this case, it was 2 times a times 4, or 8a. And this is always your last term squared every single time. So our last term was 4 squared. And it's not really necessary to memorize this pattern because you can always multiply it out and see what you get. But it's something to notice for when we start to divide, which is really factoring. So E, very similar to this one with a little twist. So if we multiply our first term here, m times m, we get m squared. Then m times 2n gives me 2mn. Then if I do my next term, I have negative 2n times m, which gives me negative 2mn. And then finally, I end up with negative 4n squared. And we can see here that something simplifies, something crosses off. We have plus 2mn minus 2mn, and those go away, and we're left with m squared minus 4n squared. So something else to notice, if you have the same terms, but one's positive, one's negative, like we did back up here, your middle term should always cancel out. Your first number here should be your first term squared, and this should be your last term squared. And this should always be negative. Because in order for something to cross off, one of your things had to be positive, one had to be negative. So this blue one up here, this is called a perfect square trinomial. And this one down here is another one that we just need to remember when it comes time to factor. If you want to try C, go ahead and pause the video and I'll write the answer up there. Alright, for C you should have gotten 8m to the fourth minus 25m squared times n plus 3n squared. Last multiplication one that we're going to do, trinomial times a trinomial. And instead of double distribution, we need to triple distribute. So I have 3r squared that needs to be multiplied by everyone here. So I have 3r squared times r squared gives me 3r to the fourth. 3r squared times 2r gives me 6r cubed. 3r squared times 4 gives me 12r to the second power. And then distribute the minus r here. So minus r times r squared will give me negative r cubed. Minus r times 2r gives me negative 2r squared. And then times 4 gives me negative 4r squared. Or just plain old r, sorry. And then finally, the very last one, positive 5 times everybody. So this gives me 5r squared. And then 10r. And then no more r's, but we just get a 20. And then we have to go through and combine the things that are alike. There's only one r squared. So 3r squared there, or r to the fourth. And then r cubed, I have 6 minus 1, so I end up with 5r cubed. And then r squareds, 12 minus 2 will give me 10r squared. Oh, I have one more r squared. So this gives me 15r squared. And then just plain old r's. I have these guys here, so I end up with 6r plus 20. No one to combine with. And we're done. Alright, very last problem. We need to find the area of the courtyard around the pool. I actually want you guys to think through this one on your own. Go ahead and do it, and then we will discuss it in class the next day. Think about what you know about areas, length times width, and you want to find the area of the courtyard. All this stuff here. And all you know is the area of the whole shape and the area that the pool takes up. So go ahead and think through that one, and then we'll talk about it in class tomorrow.